Good morning and welcome to the CADclass
Welcome to the
podcast.
what, Josh?
Yeah, that's
Welcome to the
right.
what?
That's right. I said that. I said it. Welcome to the
Oh, good.
CADclass. I'm Josh,
I'm Jake.
and every week we talk all things 3D printing, making, slicing. Show off your projects. We do all the cool stuff. And Jake, we have some cool projects to show off today. So
We do.
good.
I'm really excited about how much activity. So just because I'm working on so many different projects and books and courses and this and that, there's like larger and larger intermittent times that I get to see on Discord. And so it is every time I go there, it's like huge amount of content, huge amount of activity, which I mean we always love seeing. And so
Love it.
every single time I go there, I get to be stoked. Because when we first started this Discord, we had a handful of people from our beta testers. It was tiny, and we got maybe one post a day. And now we're just flourishing, and it's so rad to see everyone here. So just right off the bat, massive thank you to our big community because we love to see you guys coming back.
It's growing. It's getting better. It's so cool. I'm now seeing community support community. People are hopping in, answering questions. You know, this is when we imagined what we might be able to build with a community. I mean, I think two things here. One, we had no idea how hard it would be and how much time it would take to actually build these kinds of things up.
No, it doesn't take that hard. It's not hard at all, actually.
Yeah, no, it's really easy. You just, put a chat up and then it just happens.
It's fine. It's fine.
But two, I think I may have actually underestimated how much power this community will eventually have and already is starting to have in terms of just connecting people and ideas and getting the information and answers when you need them. So Mr. Mitnick, PC Van Vliet on here. Again, big thanks. I see Sam. He's agreed also to be a bit of a moderator there. I've seen him pretty active. I've seen Joe Street answering tons of questions. So you guys
So big thank you to all of our moderators. Rock. You guys kick ass.
And really quickly here. So good morning. Good morning, Joe Street. Good morning, Aaron. Good morning, PC Van Vliet. Good morning, Sam. Who are we missing? Coming down here. Johnny Yurtafan, Spitfire. Aaron, if I didn't already say you. Ogre, Cadence. Man, it is really nice to have you all. Good morning. All right, Jake, let's show some projects off.
I think, let's jump into it. So, as always, I'm usually the one seeing these at the exact same time as everyone else. So I kind of want to go into the I made a thing. I'm going to scroll down to the very bottom. I did take a little sneak this morning, but that's fine. This thing that Wookoo's making. A friend of mine wanted an enclosure for his Vocor screen to fit a VRS wheelbase. I don't know what any of these words are, but that's rad. It looks like it's a screen mount for. Oh gosh, what is that? Oh, I bet it's a VR racing thing. I bet that's what it is. Oh, that's really awesome. And then it looks like they actually printed it out. That's a really nice print. Can I just say one of the best things that I've found about 3D printing that has elevated it so much is a textured build plate. Like for a lot of people, some of the original build plates were just on glass or paper or tape. Like they were absolutely terrible. And so you always had one surface of your print that looks like garbage. And now on all of our prints, like the very first layer looks so nice and textured, you really can't tell that it's even a 3D printed. And so you always have one surface that just looks so rad right off the bat. So this is just another really great example for that. That turned out fantastic. I love to see that kind of stuff. And then scrolling up a little bit, Kid Snicket, I think new. I'm not sure.
Cadence. That's Cadence. That's Cadence.
Oh, is that Cadence?
Yeah.
All right. Finally finished some custom speaker housings for a Vespa scooter. That's awesome. Yeah, those look really clean.
I hope the Vespa. Man, I can't talk this morning. What the
Come on,
heck?
Josh. What's going on?
What is actually going on with my voice? I'm like
you either had too much coffee or too little coffee.
I think too little. I chug coffee. You know what? I'm not even going to say what I was going to say. I'm just going to just ignore me for the day.
All right, fine.
Take it away.
Jerry's checking out it. 18 hours.
With this though, Cadence, I'm curious what you printed that out of. I hope that Vespa is not a Sacramento Vespa where it gets to like 120 degrees and that, maybe one day somebody comes back and part of their speaker mount is a little, shall we say, runny.
A little melty.
Yeah,
a little runny. That's a really.
So I'm curious. if you're in here, Cadence, what did you print that out of? And is that the final thing? And maybe one small suggestion would be use a higher temperature filament like
Probably
um,
PETG is coming to
PETG.
mind for this.
Yep.
Um, uh, yeah, the scariest part was checking on an 18-hour print at hour 12, realizing the support had detached from the bed and turned into spaghetti. Propped up with a couple business cards, opening. Yeah, and it does work. There's actually, I don't think it's available on Cura anymore, but there was a setting where instead of using like infill, like laying down an actual pattern and printing, it would just spaghetti the inside. Like it would use a fantastically small amount of material, but it would just randomly squirt in a bunch of plastic that would just like as soon as your part was done, it would just jingle around. And for a lot of people, they're like, "Yeah, it works great," and it takes my 5-hour print to like 2 hours because it's using so little internal material. But at the same time, there's always a gamble that it actually doesn't work whatsoever. So if you have support material and it's all internally held, having it go spaghetti is not the end of the world. It could still correct itself, but spaghetti on external supports, that's just going to fail. That's bad news. So but propping up with business cards with actually supporting, that's genius.
I
That is
love that.
so good.
I love that.
And then it looks like the final print just turned out fantastic.
It looks
Um,
amazing. Yeah.
I would kind of imagine that. So it looks like this surface right here, if you can see my cursor, Josh, was actually on the build plate and all the material on the inside. And it looks like just going through the other pictures, if I can just see it, it's kind of conically angled. So if it was me, I probably would have printed it in this orientation and then just put supports around the outside because that's a lot less support material. Um, the other thing I'm noticing with the supports is that these are very blocky. So I imagine Cadence is just using the normal infill. And I would probably push them to use the tree support just because it uses less material, less time. More importantly, if you have less time on your print, it's just got a better chance of
It might not
succeeding
fail.
because
Yeah.
it's not spending as much time in a precarious state. The other thing that I found that really helps a lot of people out, I'll actually do a little example. I'm going to go to Cura really quickly, and I'm just going to open up something. I'm going to do a parts drawer. That's fine. This thing can have some support material in there.
What is it that you
If
say,
I
Jake? I think I got this for you. Para exemple.
Para
How's that?
example, yeah, that's fine. So if we just slice this up normally, obviously this isn't going to work too well. There's overhangs, yada yada yada. Um, but if we wanted to put in some support material, there are some settings that I really recommend people doing. Obviously, generating support is the way to go. Set the support structure to tree. That helps out a ton. The branch angle, that is literally the angle that the branches of the trees are going off. And then the support overhang angle is 65. That is my minimum of what I would then put some supports. So anything more horizontal than that, I do want some support material on there. Usually this is set to 45, which is completely unnecessary. 3D printers can print at 65 degrees all day long without needing any support whatsoever. And so if you have it at 45 degrees, then it just means that you are essentially having a really rough, ugly surface on a place that you don't really need to, because every single time you separate support material, it's gonna look bad, just kind of truthfully. Um, the other thing that you may notice is that my support material is actually dual walled. So my support wall line count is set to 2. So this gives me a little bit more rigidity in my support structure, and it means it's not going to fall over as much. But because this is such a short print, physically in height, not in time, I could actually get away and put that down to just 1 line count. That's fine. Anything where it gets a little tall, I usually put on 2 walls. That's the way to go. But one thing that I do want to kind of put people on is on this one, there is actually no brim to the support material. So I actually do want to have that. But as you can see, I actually already have enable support brim. I even have it set to 15, and it's not showing up whatsoever. And that's because my build plate adhesion is set to none. So I actually have to reset this to brim to then enable that. The downside is that if I then set this to 0, it's going to give me an error. And so you kind of have to balance between having a brim on your part, so you have to do a little bit extra post processing work, but usually that little bit of work absolutely gets made up for by having a successful final print. So putting brims on your support material is absolutely essential, and then having 2 walls is the other really good trick.
And Jake, where should people go if they want to learn more about Cura?
That was a very, very, very not not sly plug
Where
whatsoever.
should they go if they want to, just in case
Yes,
you
if
want
you
to
want to.
learn from somebody
So we
who's
so we recently published our advanced Cura course. It's kind of an extension of our 3D printing community. So if you find that you were getting into 3D printing and you're starting to make anything that you want to do, and you know that there's more to get out of your slicer program because they're quite intimidating programs. They totally can be. They're meant to, well, be easy to get started with, and that's fine. But there's so many settings and so many terminologies that a lot of people get kind of worried about. And hopefully, in our course, we've kind of said, well, we're going to show you only the ones that you really need to know and disregard ones that you will never really use. So if you guys want to check out the course, we do have some free lessons in there. So if you go to the course, you can take some of the classes completely for free. If you find that you like it and you want to take more of the course, that is now available, but absolutely no pressure whatsoever.
David Dickens says, "Will you be doing one for Prusa Slicer?" I think at some point we will. I think we
Potentially
will.
in the future.
Yeah, and we're going to continue. I think speaking with the folks over at Prusa. I'd like to do it in collaboration with them if possible. So
Mm.
maybe is the answer, David. But we'll probably put. We were just talking before this pod. We will probably put out some content related to Prusa Slicer regardless. The question Jake
Mhm.
and I are asking ourselves is, do we want to invest all the time and energy and effort into building a full on course for it, or are the materials that are available now kind of good enough? So TBD.
The thing about Prusa that really separates it. So just a little bit of context. So the people who make Cura is from a company called Ultimaker, who make very expensive, very, very lovely 3D printers. Enclosure, LEDs on the inside, camera that you can monitor anywhere in the world. It's got pre-built all of the goodies, but it was like a $2,000 printer for a long, long, long time. What we see as like the Bamboo X1 Carbon, all of those really lovely printers nowadays, that's kind of what Ultimaker was a few years ago, like 5 years ago. They're less and less popular. It seems that they're putting more and more more and more eggs in the basket of Cura. But I'm excited to see where they go. So they don't do as much outreach and education on Cura. They just kind of make updates and put out an article, and that's really it. The difference with Prusa is that they really kind of, well, their whole shtick is this is an expensive printer because we provide so much information, so much customer support. You can literally call
Yeah.
them any time of the day and say, I'm having a problem with A, B, and C, and they'll be able to answer it. And just other companies just aren't able to do that. So there's already a huge amount of information about Prusa Slicer. We may do it in the future, but it's not
It's not top of our
super,
list.
super critical. No, no. We
Not top of our
much
list.
more want to make some robots instead.
Definitely. But I do think there's
Yeah.
room for some Prusa shorts. And Jake and I were saying what's interesting about the Slicer program, we had Pooch from both Repcord, and he's a rep over at Prusa right now. We had him on yesterday, and we were saying one of the things that is starting to get interesting with these slicing softwares is how they're becoming heavier CAD softwares, really. And they can do things that you wouldn't think that usually you would have had to do them originally in CAD, but now you can cut
Mhm.
your model up and, for example, make dovetail joints automatically where you make that cut. That's tricky to do in CAD and really simple to do because they've made that workflow so easy. So Jake and I are probably going to
Mhm.
produce some content saying, hey, these are some situations you might want to consider using the slicing software instead of CAD, and maybe vice versa as well.
Mhm. There's a few things that I see people starting to do in CAD that I really, really go, no, do it in your slicer. It's so much easier. but there's no real rhyme and reason about why you should do it in CAD or why you should do it in Cura or Prusa Slicer. And it really comes down to just being pretty knowledgeable about the limitations and the benefits of working with meshes in different CAD softwares. So, for example, if I want to put a bit of text over a Benchy, well, I have to download Benchy from the internet as an STL. That's a mesh. Cool. I can pull that into Prusa Slicer as a model, plop it into the middle of the build plate, make some text, and smack it onto the side of the wall, and it works very easily. But if I want to do that in CAD, I have to first convert it from a mesh, an STL, into a 3D object that will tessellate it and turn it into, instead of a nice smooth surface, into a bunch of triangles and polygons. And then to emboss onto that, you then need to make an angled offset plane, which is a nightmare to do sometimes. Make text, emboss it, and then it goes, well, instead of just one smooth compound curved surface, it's now hundreds or thousands of little polygons. And it's like, oh my God, I have to do it for every single one. It's a nightmare. And so there's a lot of tools where it is just so much easier to do it in your slicer. Most oftentimes, if you're just trying to modify an already existing STL that you get from, Thingiverse or Printables, anything like that, do it in your slicer. But if you're going to be doing or making something yourself, it's probably a better idea to do it in CAD.
There you go, with the gold. All right, let's show off some more project. Yeah, that's great.
Oh, yeah, that's right.
Yeah, we're here to talk, just so you know. Yeah, it's all about us. It's all about us here.
Oh, if you guys are interested in checking out the video we did yesterday with Pooch, that's live, or it's in our YouTube page. Go onto the live tab and you can watch it. It's a little long, but it's a lot of fun.
Yeah, we had a good time.
We had a really good time with that. All right, I want to show off some more goodies. This one really caught my eye.
Yeah.
I made myself a wall mount for my Radio Master Zorro. That's a nice, neat print. What printer?
And who was it? Who was it on Discord?
Dairy Air. Who is? I can't believe you still get a kick. What kind of printer is that? Is that a K1?
Go back. It looks like a bamboo. Maybe I can't really tell.
Might be the bamboo. It's a
really
it's a gray.
Yeah.
Anyway, lovely prints. Nice. Radio Master, not bad. Oh, this is for the. Oh, gotcha. This is for all of his drones. That is really rad. Dairy Air, we may be reaching out to you because we are going to be putting in a drone CAD project into edition 2 of our book that we're currently developing right now. So you may be getting a message very soon going, help.
What are we doing? We don't know anything. Help.
I'm not sure I've seen this person. Electric Fish 9 printed a modified air filter that holds charcoal pellets. I used some red ABS for a project and put some faces on it. That's awesome. That's really rad.
I love it.
I do like anthropomorphizing, which is a super fun word to say on its own. Anthropomorphizing, just like super standard stuff. Yeah, that's awesome.
It gives it so much character.
I think this is a little bit of a good discussion point.
Okay.
How much do you actually know about like the science behind the plastic particles that come in the air off of 3D prints? Like, how necessary is a carbon filter?
Depends on what you're printing. I mean, you're talking with PLA or what material specifically?
Yeah, or just plastics in general. Yeah.
They all have different properties, so they're going to off gas different amount of particles, and so it really just depends on what plastic you're talking about. And to that point, it also depends on which. Remember, we talked PLA a few weeks ago, and we're like, hey, it's not actually all the same thing. So it really depends on what they put in the PLA and how much it's off gassing in your room. I mean, it's a hard question to answer. I'm guessing you know a little more than I do, though, based on that framing.
So I do a little bit. So I was just wanting to ask the chemist, but I do have a we do have a resin printer, an SLA printer, and we purchased these little white. They're just over there. I can't reach them. These little white towers, and they do have a little carbon filter. This the weakest fan on the planet, and it just kind of sucks in the air and filters it around. And I got them because they were like $20 or something. I was getting a bunch of kit for it. I'm like, fine. and they really don't work that well. Of what I've read on different forums, people are like, totally not necessary. Don't get them. They don't do much. If you're actually wanting to suck away all the noxious fumes from it, you need to get an air filtration system. That's just how it goes. And that's what we then built for the rig. And yeah, it works a billion times better. But I have read some articles where it goes into the even just printing PLA. Some of the like micro or nanoplastics they actually do get airborne, kind of
Yep.
distributed. I don't know how much a carbon filter would do though.
It'd probably have to be pretty fancy, right? Because the size of these particles they're just so tiny. So
Yeah, yeah.
I don't
There's
know.
like a HEPA filter.
Exactly. You'd want more sophisticated filtering mechanisms for that. I think point being, I saw somebody post here. If you're in a room, take precautions. I would say at least ventilating while printing. Exactly. I think
Yeah,
Jake. I think the one of the big things that one of the big questions in our lifetime is going to be how are these plastics affecting us?
yeah.
And there's still ongoing research about microplastics are kind of all the rage, and for good reason.
They're
It's
so
like
popular. Yeah,
we use plastic for basically everything, but people
yeah.
talk about microplastics and they're like, we don't actually know. We know they can cross the blood-brain barrier. So we
Yeah.
know they can lodge them and we know you can find them in clusters now. They're hard
Mhm.
to actually track down for a lot of reasons in the body. But
Oh,
I think it's going to be one of the great questions. And if you are in science, if you're doing science right now, that field is pretty interesting from
mm.
an intellectual standpoint is what do these
Terrifying,
do?
but certainly interesting.
Well, and in some ways, I think it is terrifying, but in other ways, maybe the answer for some of this stuff is it just gets treated like fiber in your body, and you just get rid of it, right?
Mm,
Maybe your body systems has a decent filtration system itself. I'm not suggesting that's true for a lot of these plastics or at any of
mhm,
them really, but there
mm.
is a possibility that that the hype is a little overblown on the in terms of the impact that they have, and there's also the possibility that it's the opposite, that it's underblown and that
It's
these things are
terrifying, yeah.
having a gigantic impact on our health. And I'm very curious to know. But long
Because
story short,
there's really not any as far as I've read, there's no long-term studies on at least 3D printed plastic effects on human health for
I think
any
there
technology. There's
I
no
think there
long-term residential studies.
I think that's changing. There's ongoing studies now. People
Good.
are yeah,
I wanna see
people
them,
are
yeah.
very, very interested in that question. But it turns out it's hard actually even to identify the microplastics themselves.
Yeah.
Is how you can't they're hard to see, right? So like
It's
I
like the
just
minimum or the maximum size of microplastic is like 3 millimeters, I believe, but it can go down to into the hundreds of millimeter. And then there's nanoplastics
Yeah, these I'm
beyond
talking
that.
really, really tiny stuff, right?
Yeah.
They're basically just shining light and measuring diffraction patterns and making predictions about what
Mhm.
may or may not be there as a result. I just read a paper last week, I think, talking about that. But yeah, if you're working with plastics and you're heating them up, I would just kind of assume that you're releasing some
Yeah.
particles, and you should take some minimum precautions to just ventilate.
Yeah.
If you're in a big room and you're not so close to the printer, I wouldn't sleep next to mine. I'll tell you that. But if you're in a big room and it's well ventilated, I wouldn't worry too much about it. If you're printing PLA, now if you're
Yeah.
printing ABS, ugh,
That's a different story. Yeah.
ugh, right,
Do you
pretty nasty stuff.
is a little trivia for you, Josh. Do you know how much plastic the average American consumes in a week?
Oh man, uh, an ounce,
Huh?
an ounce of
An
plastic.
ounce?
I have no
That's a
idea.
lot.
I have no idea.
It's almost exactly a credit card of plastic per week. Is that bizarre? Yeah, that's so strange.
That's
Coming from
really
drinking and
insane.
eating and breathing. Yeah. It's
Yeah,
really, really bizarre. It's
yeah.
it's kinda spooky. Yeah.
Yeah, yeah. I mean, I switched. I don't like drinking out of plastic. I could not understand the plastic
Mhm.
water bottle. Like people would be like, "I don't drink tap water. I'm gonna have mine in this plastic bottle." And I was like, like what planet do I
Why?
live on that you think drinking filtered water in a plastic bottle is better for you than drinking it out of almost any tap, at least in the US? Like,
Yeah.
what are you talking about? And I've gotten into arguments with people who are like, "No, no, no, this is like filtered." And I'm like, "Yeah, filtered, and then it's sitting in plastic. What are you doing?"
In the
Anyways.
hot sun, yeah.
Yeah, all day. And you take a drink of it and you're like, wow, that tastes like plastic because
You know, for anyone that's come to Southern California and has drunk, LA tap water, it's vile. Um, but But it's a similar thing between Scotland and England. Scotland will say they have the best tap water on the planet. For some reason, that's something they want. They're like, yeah.
New
And then
York says
anytime
that too.
they vacation in England, they go, oh, tap water's
Oh,
disgusting.
that's New York.
I'm
That's New
like,
York.
you should drink LA tap water. It's
Oh,
it's
it's truly terrible. You can taste the chemicals in it. Any
yeah.
ways, we're not here to
I
talk
think we
about that
should.
stuff. I do think this discussion is relevant though, especially for the 3D printing community. You're going to get a lot of
Yeah,
questions if you spend time in this. So good stuff.
yeah.
All right. Uh, back
I
to it.
want to show off a little project that I made over the week.
What you
For
got?
the first time, I know it was so popular years and years ago, and I never made it, and I really wish I did, and now I have. But I have made a tensegrity tower, which I'm
Yes.
so stoked to make. This has been on my docket of things to make for so long, and I absolutely love it. I really dig kind of funky, weird physics, engineering models, and this thing is just so rad. But this will be coming in the second edition of our book, Mastering Fusion 360, as a replacement to the filming guide. Something that was kind of utilitarian, and people were like, it's a little boring. And our kind of factor of what projects that stay and projects that kind of get next is a cool factor.
Yeah.
It's like if it doesn't have a certain degree of coolness, like it's gone. If people aren't like really stoked and excited to make it, it's done. As simple as that. So regardless of how useful all the tips and tricks is, it's like you got to find a cooler project to put it in. So
Amazing.
the filmic guide is going to be gone. For anyone who has purchased a book and is here, or has just downloaded the book, um, the online PDF will always be updated with the most current version of the book, completely for free. So if you bought our physical book the day before we actually change it, you will always have access to the most newest projects forever for free until the end of the universe. That's fine.
Wow.
Um,
Wow.
yeah. I have one on my desk and I can't get the strings tied. So um, we'll go over this in the book, guaranteed. But this just uses fishing line that's then threaded through a hole and then just secured with some bolts. So as long as you can have all of the strings just loosely secured at the bottom, you can then pull it through the top, drape it over the side, put a bolt in there really loosely, and then you just kind of pull on all the wires until this top thing is flat. So getting the tension in there is actually not a problem whatsoever. It's lining it up so everything's nice and straight. That's the
I love
hardest
that.
thing.
That's a super fun project. I
I
think
know
like
this
to
is
your
rad.
point, the projects that excite me the most are the ones that feel like magic.
Yeah,
Right?
yeah,
That when you get that sense of like wonder and awe that a thing is that you are looking at, that is what
yeah,
I want.
yeah, yeah.
Uh, we had a
So
question earlier and I'm realizing I didn't answer it. See if I can find it. Wow. It's funny, these now they get buried.
Uh, but yeah, we'll probably end up making a little bit of a YouTube short, just kind of promoting the book. So you guys will totally get all the instructions for this. It uses a lot of the steps and tips and tricks that we use in the filming guide, as well as a couple extra brand new ones as well. One of the things that I'm actually really excited for in the second book is going through every single Fusion article that they published over the year. I'm like, oh my god, there's so many new tools, and then reincorporating that and changing around all the projects. So I'm really stoked for all of that. Do you find it, Josh?
No, I can't.
No?
There's a question in the comment section. If you're still here and you asked me a question
Uh,
and I didn't answer it, can you ask it again? I can't find it. Wow,
That's all right.
that's amazing.
Okay. I want to go on a little more of a longer term project of a mini project today. It'll probably take the rest of the meeting. So I am still working on the Lincoln's 3D printer. So if you weren't here last week, I'm going to be starting on a long term project where the idea is Lincoln's hatchet or the boat of Theseus, I believe. Where the idea is if you replace a part with a replacement, is that object the same object? If you remove the handle off of Lincoln's hatchet and replace it, is it still Lincoln's hatchet? That's the kind of idea. And so we just thought it'd be really fun to replace as many parts on an Ender 3, totally standard, with a 3D printed replacement. and then continue on to see exactly how much you can actually remove. But the challenge is every next part needs to be 3D printed on that printer. Oh, is this a question?
This is the question, yeah. So thank you in the comments. Somebody said it was Spitfire, and it was indeed Spitfire.
Can you add a plane onto the surface of an STL that's been loaded into Fusion 360? Yeah, let's do it. I won't show you a model because it'll take a little too long to actually upload. But super duper easy. But there's one button that everyone always misses. As soon as you actually import a model, these are step files. Doesn't count. You'll want, as soon as you have your STL in the middle, you'll want to go up to Mesh, and then you'll want to click on Convert to Mesh. That's at the very bottom of the Modify tool, and it's basically asking for select the body that you want. Don't worry about the operation of the method. As soon as you click OK, it will convert it from being a mesh, which is essentially just a surface. It's a blanket that goes over a 3D object. Then it will actually be a model, so a solid thing. And then all of the different faces will be clickable where you can put offset faces on. So that's the idea. But going back to
which project do we show how to do that in the silicon molding project?
Yes, we do. With the skull.
And
that's in chapter 3.
Chapter 3, silicon molding skull. And then do we do it? Is that the only one we show it?
I don't know. It's been a while.
It has.
It's been a while.
Wait, who wrote this book?
I don't know. But the limiting factor is anytime you're importing an STL to be edited with CAD, be careful because it's very tricky. It's just the wrong tool for the job. You can kind of think of it like I have a piece of paper in my hand and I'm taking a picture of that, and then I'm uploading that picture to like Microsoft Word, and someone says, "Can you just change that word? Can you capitalize that?" And you're like, "Well, yeah, I could rewrite the whole thing and then change it, but kind of no, like practically." So that's kind of how you have to think about it. Editing STLs is where you want to do it in slicer programs like Cura or Prusa Slicer. If you want to change something about a pre-existing model, make sure it is a step file or STP. That makes life so much easier.
Jake, I have a little bit of bad news.
Oh no.
I think. Okay. So Fusion just updated, and they broke one of the tools that we use. They broke the coil tool.
No.
They broke the coil tool. So Serdar on our so the geocache hide. So actually, can we? I want to do this live on the pod right now. I know we're going to try to get to making something, but it says help please. So Serdar and the geocache hide. I can't create the coil in the dialog box. It won't let me enter revolution value to 0.1, and it won't let you change that. Okay. So I want you to open it up. I just saw this on Reddit, on the Fusion Reddit, subreddit, and somebody said the coil tool doesn't work as it used to. So that would be a huge bummer. But let's go ahead and open
bizarre.
up.
I'm going to make that right now. Then let me just grab one of the books really quick. I'm not going to do the whole thing to exactitude, but I do want to give you guys as much accurate information as we can. Oh, God, why do we make this book so big, Josh?
I don't know. Yeah.
Okay, so I'm just going to start off with making a cylinder on the top plane. We'll see how fast we can do this. Diameter 33, 16 mil tall, grand. Looks good. I want to add a thread onto the outside of that surface. Make sure it's modeled. Groovy. I want to change this over to an M33. Oh, whoops, I did the wrong way. Diameter 33. That one is 16. I knew it looked weird. Funky. All right, then we added on a thread. This is modeled. Groovy. Then we are cutting out the very bottom, adding on a circle to the middle. How big is a circle? I really wish I remembered the book I bloody wrote, but I totally don't. Then I'm going to be extruding this all the way through. Don't really care. Make a little triangle to cut that away. That's not important. Then I can make another cylinder below it onto that bottom surface. Great. This wants to be 40 and -8. 40 and then go down 8 millimeters. Groovy. So making a knurl is actually fairly easy. So we're going to be using the coil tool. I want to select that circle. So I'll start at the origin, pull out to that 40 millimeters. Okay, and then I'm just going to be bringing this arrow upwards. So it's actually going to be cutting in the right direction. Obviously, it's the wrong shape and size. But the diameter is 40 millimeters. Yep, the revolutions is 0.1. That doesn't like it, but we'll press on.
That's exactly the error that Serdar got. Right
10.
there. That error that you're getting.
Triangle internal. It's on the inside. And this is a 1.5. There's a cut. What the hell? Okay. So what happens if I increase it just... So it likes 1. That's very strange. If I go to 0.9...
Doesn't like
error.
It. Yeah, this is exactly what it said on the subreddit. It said anything under 1, it won't take it.
That's really strange. That's very, very funky. Why would it do that? Let me change it to a different type. So that was revolution and height. We'll do height and pitch. See if we can mess around with that. That's the inside. Don't want that. Pitch. Oh gosh, no, that's no. What? -5. Can that be a positive number? Oh, that's going the opposite direction. -1. No, that's not what I want. So what about -100? Oh, yeah, it must be based on, the revolutions of it. So it doesn't like that. 25? 20? 10? Oh my god, that is so strange. Yeah, it won't go anything above that. So even like -11 for the pitch. Oh, that's so bloody annoying. Why would that even be a thing? That's such an... Oh my god. So yeah, so that's not going to be... Yeah, so then it doesn't matter what you choose. It's just going to be restricted to 1. That's really fantastically annoying. Okay, guys, we'll show you the fix. And that is simply to keep it as 1 revolution, but to bump up the height massively so you can still get that angle. So the idea with the knurl is that to make a diamond pattern, you want this to be at about a 45-degree angle. So we're still just reaching it up. So instead of the revolution set at 1, but the height, instead of being just the height of this piece of 16 mil, just massively crank it up. That gives us our cutaway at about the right angle. Then we can mirror that feature. Mirror that coil about the front plane. Yerp. Cuts it away. And then we can do a circular pattern of the features. That would be the coil and the mirror. And then the axis is around the center. Then we can increase that to whatever we want. 20. Yeah, doesn't really matter. And then that'll solve in a second. Yeah, that works. Gosh, that's really strange.
Mm-hmm.
I've never seen that before.
I think they just introduced that bug. Something broke it.
There's no way that's a feature. There's no way that is that's a bug. God, that's so bizarre. Gosh, okay, well, I hope that helped. I hope that helped people that are actually running into that issue, because that's ridiculously annoying.
We also have that we're going to have that issue in the fire piston, right?
Yeah, as well with the any of the knurls, actually.
So anything that's knurled, yeah, we're going to have to add a link inside the course and then edit the PDF. So we'll add that to our edit list. We start for now. That's super frustrating.
I mean, we know some people in the Fusion world, so we may be able, or on the Fusion 360 team, So we'll actually be we'll definitely reach out to them and say, hey, fix it.
Yeah, super bummer.
Um,
Anyways,
in a slightly related but kind of not really, Fusion 360 is changing its name. In fact, it's already changed its
has
name.
changed its name.
Has changed its name. It is now no longer Fusion 360. It is Autodesk Fusion. Woo! Yeah, okay. Like,
What I like to imagine, can you picture just like how many executives needed to sit into a room and for how long they needed to make a decision that is, that 360 part? I don't know
it's
about it.
like, hey, Bob. So it's Fusion because we're joining a bunch of different parts of different CAD programs together. Go, yeah. What the hell is 360?
I
Oh,
don't.
Jim thought of that. Well, Jim's fired, so
Yeah, Jim's gone. He's long. He hasn't been here forever. Let's get rid of that 360. I mean, can you imagine the branding nightmare? Jake and I are going through some rebranding of CADclass right now, or should I say, I can't even call it rebranding. Let's be real. We didn't have like a
we didn't have a
consistent
brand to begin
brand,
with to
so
rebrand.
we're
That's fair.
branding for the first time, and it's a nightmare trying to sort
It's not a
out
nightmare. It's just obscenely difficult. It's way
all of
harder
the
than
different
I'm
aspects of the
expecting.
brand, the logos and the favicons and the Gmail stuff and the social media accounts. It's just like, and can you imagine what that looks like for Fusion 360?
It sounds awful.
That sounds terrible.
My dad was a coder during the Millennium crossover, and he said one of my jobs was literally to go through every single company we'd ever worked with and every single line of code that said 1999 and then change it over to 2001 or to 2000. And he's like, it was a nightmare. It was just a never ending amount of work.
It's
That sounds
brutal,
awful. That sounds
brutal,
awful.
brutal.
I imagine it's not too dissimilar to that. Oh goodness me. Okay. Getting back to my
You want to
3D
make a thing?
printer.
Yeah.
I want to make a thing as always. And I'm going to do a thing that I have seen some people do on here, or do in, well, not really our Discord, but certainly in the world. And I want to show them the lights and show them that that things actually can get better. And that is how to 3D print a plastic bolt. That's the idea. On one of on a lot of the projects that we'll be doing is 3D printing bolts that can then be used. And one of the really important features about 3D printing is that it is crappy in one direction. If you are printing a cylinder, like a water bottle, the layers that actually cut it up is the weak points. Things will always be breaking along the layer line. If you have a really small amount of surface area across the cross-sectional area, then it will break. If you imagine 3D printing something like a pencil, but printing it vertically, you can snap it really, really easily. But as soon as you print it on its side, then you've got a huge amount of surface area. Great, but it's going to be way harder to break. It's the same thing with any type of material that is technically fibrous, where it will always want to break along lines. If you have a plank of wood where the grain is running in the direction of the length, that's super hard to break. But as soon as you have a piece of wood where the grain is going along the short direction, maybe it's a cut off from a really wide plank, you can snap it really, really easy. So a really important thing that people will do for bolts is they will print it vertically, and then as they're tightening it down, the forces that a bolt works with is putting it in tension, and so it just snaps really easily. And that's a bit of a nightmare. So printing it horizontally is the best thing to do, but unfortunately, obviously, there's now overhang issues. So then you have to deal with that as a separate aspect. So you can put in some support material to hold it up, but now you're putting support material over essentially the points, like the razor edge of a thread, and it just leaves behind a fantastically crappy surface. It leaves in a bunch of material in the thread valley of the bolt. It's an ugly surface. Like technically, it's adding some gusseting to it, like putting thread lock on a bolt. So technically, it's a little bit stronger, but it's just a nightmare to work with. So one of the alternatives is to actually cut away a flat portion on the bottom of that bolt, because then you can just apply support to a flat surface, and then it's super duper easy. But the question is, how much flat surface do you need? And it actually comes back to what we said earlier.
Are
And that
you
is that
are you telling me you're reinventing the bolt? Is this what I'm
I'm
hearing?
reinventing the 3D printed bolt.
Yeah.
Yeah,
Yeah.
absolutely. Yeah.
Okay. Just checking.
So the concept is that basically all 3D printers can print at a 65-degree angle all day long without the need of support material, just fine. That is just something that I found. Anything more horizontal than that, it's actually a failure. We do have a STL for an overhang test where it prints at 5 degrees, 10 degrees, 15, blah, 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 all the way over to 90 degrees on our Thingiverse page. Josh, if you want to link it up in the comments, where it actually shows exactly how much. So it'll have the degree on the outside that's really easy to see, but on the undersurface, it starts to droop a lot. And there's no right answer. It is purely just personal preference. Some people say 45 degrees is my absolute limit, which is a little silly. Some people will say 75 is fine. That little bit of droopage is not the end of the world. So it's purely just personal preference. The steeper you go, the less support material that you need and the less cleanup there is. So there are some benefits to it, but it does mean you'll have a slightly crappier surface. The inverse to this is that having being able to print an overhang or at a certain angle, is that you can make a hole that doesn't have any drooping as long as you kind of cut the top off a little bit. So I'm going to go ahead and share my screen to do just a little bit of an example. All right. So if I'm making a hole that I'm going to be printing where the axis of the hole is parallel to my build plate. If I just make a little wall right here, and I make a little circle in the middle, and I extrude it out just to give it a little bit of depth. If I know that I'm going to be printing it in this orientation and I'm putting a rod all the way through it, everything is going to be totally fine on this bottom surface. But at the top, that's where the plastic actually will fall in and droop a little bit, and it gives you a really, really crappy surface. So it means the cylinder won't be able to pass through, or the rod won't be able to slide in very easily. There's going to be swarf, which is the more technical terminology. It just gives you a pretty crappy surface. So one of the things that you can do about it is to kind of recognize that you can print at 65-degree angle and delete some of that material. So you can basically make some tangent lines that we know are, if I just add on some tangent constraints, make these totally equal. We want to make sure it's obviously right above the center of our circle. But if we make sure that these are printing at 65 degrees, so if I make a little construction horizontal line, and set it to be, like I said, 65 degrees. Oh, whoops. It should be 90 minus 65. Excuse me. There we go. Yeah, 25 degrees. Then we actually have this kind of party hat surface to it. Yeah, there you go. So it is mostly a round surface, except for the top sections where we know these tangent angles are going to print perfectly fine. There's not going to be any droopage, and we still have the majority of a round surface. That's the idea. If that makes sense to you, Josh, then I guess I'll continue onwards.
That makes
Does
sense.
that make sense?
Yep.
Okay, cool. So I'm actually going to be treating this kind of like the underside of a bolt, where instead of a construction line, this is going to be the underside, or this edge is going to be the underside of my bolt. And this is just going to be the cross-sectional area of my bolt. So you can see the vast majority of it is circular, and there's only a small portion that is actually a flat section ground onto my bolt. But because it is only based on this degree, there's actually a perfect ratio between the diameter and the distance between the center to that line. So you can make it anything you want. So if I want to make I'll actually do the math for you here. So all the aluminum extrusion on our Ender 3 that I have up there that I keep on looking at, it's all 2020. that it means 20 millimeters by 20 millimeters. So if I have a top-down look and I can see that my limit extrusion is going to be 20 millimeters, I know that I'm actually going to be beefing out these bolts quite a lot because they're still 3D printed. So I actually think I want to have about a 10 millimeter thread, and then, gosh, maybe even like a 15 millimeter head. Does that feel about right for you, Josh?
Yeah.
Yeah. This is something that I've just been thinking about for quite a long time. Maybe even, gosh, 17.5, because it just needs to have so much meat to actually be used uh, as a bolt for 3D printing, because there's so much movement with the rack going back and forth, all these vibrations. They just loosen things so much. So let's say 10 millimeter thread and 17.5 actual head. That works. So if you've done the metric bolts project we have in the book, then you know exactly what I'm doing. I'm just making the side profile of our entire bolt. I'm going to be making this bottom flat section a center line, just so I can measure things a lot easier. So I can say the top section to there, so that means the diameter, or the diametric dimension, is 10 millimeters, and the distance from there to there is 17.5. Lovely. The height of the head, yeah, probably 10 millimeters. That's fine. And then these are 25 bolts. Remember that. So as soon as I do a revolution, perfect. But my thread is going to be an M10. Great. That's going to be nice. That's going to be chunky enough where it holds on perfectly fine for a 3D print. But I may actually want to go lower. Can I go lower? I'm 10 by 1? No. I kind of want a chunky thread, but not so much that it fails. So maybe the 1.5 is fine. I'll end up cutting the hexagon in the back, but really what I want to do for this mini project is cut the underside of there. So I'm going to be cutting a flat section on here. I can just make a center rectangle that is exactly below there. Going back to my little sketch that I had. So I say that this is a 10 millimeters. And then the distance between there and there is going to be 4.5. That's going to be perfectly fine amount of accuracy for this. I really don't need to go any more than that. So the distance between there and there, 4.5. Lovely. It's only cutting in just a little bit, which is actually exactly what I want. I don't really care about the size of this rectangle as long as it's, cutting outside of this surface area, which is my thread. That's fine. So then I can just extrude cut this rectangle, and then I'll say that my extend type is to the underside of the bolt head. There we go. So it can support all of these little cut-off surface perfectly fine. Obviously, the angles of the threads, not a problem. But this will give me a really successful print without having to do anything else with it. Even more so because I know I want it to print in this orientation where I have my flat section on the bottom. I can do the same thing for my bolt head. So I can go back to my little circular piece and say my circle is now 17.5. Oops, why is it saying that? Oh, it's because I locked it. Yep, 17.5. Lovely. Oh, it doesn't like it. Why doesn't it like it? 17.5. Grand. Yep, distance from there to there, that would be 7.93. Lovely. So I can make another sketch on that flat head. Make a little center rectangle. Make sure everything's nice and neat. Totally forgotten it. What was it? 7.93. There we go. So then I can cut off the little bottom section of my bolts. This will make it print way better. Like I said, it is the majority is still round. It is still a normal bolt. I'm just editing it in some small ways to make it as 3D printable as possible, really. And then the last thing to do for this bolt, other than put in the obvious head on there, would be to make the little triangular cutoff. Really important. I do still get a lot of people asking why we actually have to trim off this little circle or this little triangle off the corner of our print, and it's very, very simple. You cannot chamfer a bolt and then print with it. It just doesn't work. You need to have some, or you need to make the thread first and then cut it off later. That's just kind of how it goes. So 1 millimeter, it's perfectly fine. I'll say that it's 10 mil or 5 mil above there, just so we know we're cutting all the way through. Do a little revolve cut around the axis. Lovely. This is now cutting away some material following along the circularity of the bolt head, and it just gives you a lot easier to actually cut it in. If you try and apply a chamfer before you add on the thread, you don't get the same effect at all. In fact, it won't even put itself onto a bolt at all because it is a complete, almost nub. There is no beginning to this thread because it's kind of tucked under this overhang of the chamfer. So it really doesn't work at all. So you always have to do this triangular revolute cut just to kind of mirror what you do in real life. When you're making a bolt on a lathe, for example, you'd use a die to actually cut away all the material to make this thread. Then you would take a file, hold it at 45-degree angles, and then just cut it away, basically. And that's how you get the entrance of a thread to be really nice. And depending on how large the bolt is, you can then change the size of that triangle. So if I go, it's too small, I can just bump that up to 2 millimeters, and it just makes it even easier to insert into our project. So yeah, there you go. Pretty easy project.
Nice.
Yeah, not bad.
We have one final order of business, I think. And
Do we?
our challenge last week seems to have gone
Unchallenged.
unchallenged, untested. I don't think I didn't get a chance to make any modifications to the geocache and actually hide one. So I don't know that anybody else did either. But what are we going to do this week? What
I have
is
an
the
idea.
challenge for the week? What do you got for us?
I really want you guys to print some accessory, whether it is functional or purely aesthetic, for your 3D printer. But it has to be something that you design. I did see, or the guy that made the HEPA filter for his 3D printer, and then he put a little face on it. I love that stuff. I know Josh loves that stuff as well. So I'm challenging you guys to actually design something. If you can't think of anything functional, that's fine. But I want you to make something aesthetic to kind of show off your printer. I really want to see all the cool stuff that you guys make.
Amazing. So okay, we got a couple minutes here. PC Van Fleet, one of our best posters, is like, I'm sad we skipped his.
No, I will
made
totally
a thing.
go
So
back.
we're not gonna skip it. We're not
No.
gonna skip it.
That'd be very rude. Is that Mr. Mitnick?
That is Mr. Mitnick.
Gotcha. Okay.
Two things,
So today,
actually.
Oh, that's right. You did, didn't you?
Yes.
Installed my ESP32 Lite project. Concept we made in Fusion 360. Neighbor said it exceeded his expectations. That's rad. Okay.
Let's check it out.
Little blank canvas. That's pretty rad.
Keep going.
Oh, it's like a frame box.
Yep.
Okay, so I'm seeing some JSTs, little power supply, little plug. Nice. Oh, this is with the owl project.
Yes.
Oh, yes. Okay. Dude,
yes. That's so freaking rad. Derriere says, I'd love to see more photos of that project. I agree.
Whoa.
I agree.
Dude.
This turned out so well. So well.
Hope you don't mind me swearing. Holy shit.
Yeah.
That looks amazing. That looks absolutely fantastic.
Yep.
God, that's so rad. I don't even know how you did the little twinkly effect at the beginning where it just kind of flutters.
So cool. So cool.
God.
And then
Josh, we're just surrounded by people who are so much better at stuff than we.
That's right. That's exactly right. And then we sit up here and talk like we are important. It's crazy.
Yeah,
how the world works.
That's how it works.
And then just above it, check that out.
What is this? So I did a rush job for someone. Pop-up voor Lancome. Dipped in clear PETG with hydrographics. What the hell?
That's pretty crazy. So
That's
this looks like
rad.
it's really, really
It's a
that turned out
floating bit of fabric.
basically, yeah. And it's meant
That's
to,
so
like,
rad.
mirror that. I'm guessing this is is it gonna be a stand? Let's see if I look. I don't know. This is amazing. Oh, it's a pop-up store.
Damn.
Yeah, so it's gonna be showcasing some products. I look how that's an amazing, amazing organic shape.
Wow, that's
Yeah.
awesome.
Yes.
I could so that looks like just a bit of acrylic in the background, what I'm sure that he's copying. That's been kind of melted and folded into this kind of
So
windblown shape.
cool.
These things shatter so easily. So I imagine this won't survive for long, but
Well,
Mr.
no,
Mitnick is going to
this is
survive for
printed.
so much longer.
This is printed out of PETG.
I know this part is, but the one
Oh,
in
I
the
see.
picture,
Oh,
yeah,
yeah, yeah, yeah. That's
yeah.
funny.
So, God, that's awesome. That
Awesome.
is so rad.
So,
I love
on
that
that
detail.
note, Jake, this has been the CADclass podcast. Once again, I'm Josh,
I'm Jake.
and we will see you next Wednesday.
See you later, guys. Peace.